Welcome to EDU World Space.
Okay, so this is the free body diagram for the pulley C, and this is the free body diagram for the smallest pulley, and then this is the free body diagram for the pulley B. So for part A, this is the free body diagram for the man. So we can apply the force equilibrium for this case. So we have the net force on the y direction is equal to normal force plus the weight of the object over 3 times sine 45 degree minus the weight of the man is equal to 0. Therefore, have the normal force is equal to Wm minus W over 3 sine 45 degree. And the net force in the x direction can be equal to F minus W over 3 cosine 45 degree, and this is equal to 0. F here is the friction. So therefore, have the static friction is equal to W over 3 cosine 45 degree. And remember, the static friction can be expressed as the mu(s) n. Mu(s) is the coefficient of the static friction, n here is normal force. Since sine 45 degree is equal to cosine 45 degree, which is equal to square root 2 over 2. Therefore, we have the friction is equal to W over 3 cosine 45 degree, which is equal to W over 3 sine 45 degree, and this is equal to mu(s) n. So now we can use mu(s) n substitute for W over 3 sine 45 degree. So we have n is equal to Wm minus mu(s) n. So we have 1 plus mu(s) n is equal to Wm, therefore n is equal to Wm over 1 plus mu(s). So remember, W over 3 times sine 45 degree can be equal to mu(s) n, and this can be also equal to mu(s) times Wm over 1 plus mu(s). Therefore, we have W over 3 is equal to mu(s) times Wm over 1 plus mu(s) times sine 45 degree. This will give us W here is equal to 3 mu(s) Wm over 1 plus mu(s) times sine 45 degree. So we know the coefficient of the static friction is given as 0.6, and the weight of a person is 200 pounds. So now let's plug in these values back into the equation to determine the W, which is equal to 3 times 0.6 times 200 pounds over 1 plus 0.6 times sine 45 degree. And this will give us W is equal to 318.2 pounds. So now for part B, since there's a pulley A presented, therefore this is the free body diagram for the person. So now we can still apply the force equilibrium. So we have the net force along the y direction is equal to normal force minus the weight of the person now, which is equal to 0. So we have Wm is equal to n. And the net force along x direction is equal to friction minus W over 3 is equal to 0. So we have F is equal to W over 3. Remember, friction can be equal to mu(s) n. So now this can be equal to mu(s) Wm as well, since n is equal to Wm. So now we have mu(s) Wm is equal to W over 3. Therefore, W is equal to 3 mu(s) Wm. We know the static friction's coefficient is 0.6, and the weight of a person is 200 pounds. So now let's plug in these values back into the equation to determine the W, which is equal to 3 times 0.6 times 200 pounds. And this is equal to 360 pounds. And these are the answers for this question.